We'll be doing a compound inequality in this problem. Notice it says solve the compound inequality and give your answer in interval notation. There's an and in between these two inequalities. So what we need to do is solve each inequality individually, and then we'll take the overlap between our solutions. So here 0 times x is just 0, plus 2 is greater than negative 4x minus 22. Let's add 22 to both sides so that we can isolate that variable of x. That gives us a 0 here, so that's gone. So we actually have 24 is greater than negative 4x. When dividing both sides by a negative, we reverse the inequality symbol. So this will say x, instead of being less than, we're going to turn it into greater than negative 6. Now we'll solve the other inequality separately. We'll distribute this 3 throughout. So that gives us negative 9x plus 12 minus 3 is greater than or equal to 12x plus 120. Okay, we want to isolate our variable. And I'd like to end up with a positive coefficient of my variable, so I'm going to add 9 to both sides. Or this should have been 18. 3 times 6 is 18. All right, so if we add 9x to both sides, this will give us a 0 pair here. We can add 9x here. 9 plus 12 is 21. So we have 21x plus 120 is less than or equal to 18 minus 3 is 15. Now we'll subtract 120 from both sides. So that gives us our 21x, as we have a 0 pair here, is less than or equal to negative 105. 15 minus 120. Is this negative 105? We're going to divide both sides by 21. We've got x is less than or equal to negative 105 over 21. Which is negative 5. So in the end, we have x is less than or equal to negative 5. So now we're ready to deal with the and portion of the problem. For the left-hand inequality, we have x is greater than negative 6. But we also see that x is less than or equal to negative 5. So let's look at where we might have some overlap here. All the numbers have to be greater than negative 6. Put on a parenthesis, point it to the right. And then x is less than or equal to -5. So we put on a -5 here and go to the left of the -5. All the numbers smaller than or equal to -5. All right, now for our final answer, we need to take only where there is overlap between these two graphs. So all the x's greater than 6, but less than or equal to -5 would be this region here. So from -6 all the way over to the -5. X has to be less than or equal to -5, but greater than or equal to 6, and over the overlap. You also could write this as x is in between -6 and -5. Would be the inequality notation. Now, what if this whole problem, instead of saying and, what if it had said or instead? Well, you first solve each individual inequality, just like before. We get x is greater than -6, and here we get x is less than or equal to -5. But for our answer, we're going to take all of both graphs. So if we look at that number line here, x is greater than -6. So we'll put on our -6 with a hole in it to show that it does not include -6, and x is greater than -6. So all the numbers bigger than -6 out to positive infinity. Then we need to look at x is less than or equal to -5. So here's -5. X is less than or equal to -5 all along here, all the way out to the real numbers. So if it's an or situation where you're taking all of both graphs, in this problem, if it were being an or problem, we see the whole number line is shaded. You can say from -infinity all the way to infinity. Or you can write all real numbers.